Okay, I want us, for our first example, to find all possible, why are we talking? Rational roots and for this one it's going to be 4x cubed minus 16x squared plus 11x plus 10 equals 0. Okay, so remember, we want to list the factors of the constant over what? Factors of the leading coefficient. All right, so our constant is 10. So let's list those factors. We're plus minus 1, which pairs with plus minus 10. Then plus minus 2 will get matched with plus minus 5. Any other factors? No, so we stop there. Now we're going to do factors of the leading coefficient. Our leading coefficient is 4. So this is going to be plus minus 1 paired with plus minus 4. Then we have plus minus 2, and it's another 2. Any other factors? No. So now when we come to make the list, what do we have to do? We have to pair every numerator with each denominator. So the first one will be plus minus 1 over 1, which is 1. But then we're going to have plus minus 1 over 2. And then we'll have plus minus 1 over 4. You got it. Right, now let's go on to 2 in the numerator. So we can have plus minus 2 over 1, which is just 2. And then we could have plus minus 2 over 2. But what's 2 over 2? 1. And then we'll have plus minus 2 over 4, which simplifies down to a half. Do I already have that? Yeah, I don't need to write it again. Now let's go over to the 5. So for the 5, I can have plus minus 5 over 1, which is just plus minus 5. I can have plus minus 5 over 2. And I can have plus minus 5 over 4. Now we are going to the 10. We can have plus minus 10. Well, what's 10 over 2? 5. Isn't that already accounted for? Yeah. And then we could have 10 over 4, but isn't 10 over 4 5 halves? Already accounted for. So here's our list of possible rational roots. Exactly. Do you think I'm always just going to ask you to find the possible? No. So now let's step it up. All right. We are now going to find all the rational roots for a function. So now my directions are find all roots. So not just the rational ones. Now I want to find all roots for a function. Claire? You can pull it out. You can pull it out. Well, it's not really going to ultimately make a difference, but yeah, you can pull it out. All right, so we want to find all the roots for a function. I'm going to tell you the steps. I'm going to write out the steps for you. So first we're going to list all possible rational roots. which I had said the other day was P over Q. What does P over Q represent? Factors of the constant over factors of the leading coefficient. That's P over Q. Okay. Then we're going to test the possible rational roots with synthetic substitution. It's like the synthetic division. To see which give a remainder of 0. Then we're going to continue with the synthetic substitution until you get the function to a degree of 2. Then after you get it to a degree of 2, we are going to factor or use the quadratic equation, quadratic formula, whatever you want to call it, to find the remaining roots. It is horrible. All right, do we all have this down? We ready to try it? 1 second. We good? Okay. So, I'll start off kind. I'll just have a degree of 3. I'll just give us a degree of 3. So, I want us to find all roots of x cubed plus 3x squared, or sorry, f of x is equal to x cubed plus 3x squared minus 6x minus 8. Okay, what do I want us to do? Step 1, list all possible rational roots. So list all possible rational roots. And how do we do that? Factors of the constant over factors of the leading coefficient. So do we agree our constant is 8, negative 8? So we are at plus minus 1, plus minus 8, plus minus 2, and then plus minus 4. And I was kind to you. Why was I kind to you? The leading coefficient's 1. So this is just plus minus 1. All right, so now we're going to list them, which is really just the numerator. So we are plus minus 1, plus minus 2, plus minus 4, plus minus 8. So now that we have, these are the possible rational roots. So now, according to my steps that I've given you, now I'm saying let's use synthetic substitution to plug in and see which one will give us a remainder of 0. Because if we have a remainder of 0, what does that mean? That it is a factor, right? So it doesn't matter where you start. Where do you want to start? Do you want to start at, let's start at 1. I want to show you one. All right. Is every exponent accounted for here in our original polynomial, x cubed plus 3x squared minus 6x minus 8? Yeah, so I could just list these out. So we're at 1, 3, -6, -8. So now you put the 1 in the box and you bring it down. Bring down the 1. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. -6 plus 4 is -2 times 1 is -8 plus -2 is -10. Is this a factor? No, our remainder is not 0. So now let's go to -1. You only need to get it down to a degree of 2. Once you get it down to a degree of 2, then you can factor or you can use the quadratic. But it's all about guessing which one to use first to get it down to that degree of 2. So now let's check -1. So again, we're at 1, 3, -6, -8. Bring down the 1. 1 times -1 is -1. 3 plus -1 is 2. 2 times -1 is -2. -8 plus a -2 is -6 plus a -2 is a -8. -8 times a -1 is 8. -8 plus 8 is 0. Does this work? Yes, because the last column 0, that means it went in evenly. So what does this mean? This polynomial that we have here is going to be 1 degree less than our original polynomial. What was the degree of our original polynomial? 3. So this has a degree of 2. So then this is x squared plus 2x minus 8. But now, don't forget, this one ended up being a factor, right? So this was x equals -1. If x equals -1, what was the factor? X plus 1. Are we okay so far? Okay, so now we agree x equals -1, that is 1, 0. Yes, we agree that's 1, 0. We have to find the other 2 zeros. Can we factor this to find the other 2 zeros? Yeah, we can factor this. So I'm going to go ahead and I'm going to factor this. This is going to be an x plus 4 and an x minus 2. So what are my other 2 zeros? -4 and 2. So then we list them. Zeros. X equals -1, -4, 2. All right, can you write them as points? Absolutely. You can write zeros. You can have -1, 0, -4, 0, 2, 0. Either way is acceptable. Let's go to Desmos. Huh.
And whenever you what is that?
Okay, so guys, look. This is what it looks like. So here, let's look at our roots. We're at -4, -1, and 2. In this scenario, all the roots ended up being what? Rational, right? All the roots ended up being rational. So let's go back just for fun, because this is what fun is, right? So just for fun, let's see if all of those were in our original list, right? We said -1, -4, 2. Go to your original list of possible rational roots. -1, what was it? -4 and 2. So basically, originally, you know, when we used our synthetic substitution, you could have put any one of those in as your first starting point. So you didn't have to start with 1. You could have gone to the -4 and put that in and then got it down to a degree of 2. Do you all see what I'm saying? Yes.
So is it possible you get to like, you do all of them and it turns out to be -8 and then you just did like synthetic division 7 times?
Could be, yeah.
Wait a second.
Okay, let's do another one. All right, so now I'm a little bit meaner. Why am I going to be a little bit meaner? I am now having a degree of 4. You want to try this one on your own? Find all roots. So now when I say find all roots, that means the roots don't only necessarily have to be rational. They could end up being irrational or also imaginary. So we're going to we'll do this one together. G of x is equal to x to the 4th plus 10x cubed plus 33x squared plus 38x plus 8. So where do we start all of these problems? By listing what? By listing what?
The constants, all
Mhm.
the possible factors, and the leading coefficient.
Yep. So the possible rational roots. So we are going to have the factors of the constant plus -1, plus -8, plus -2, plus -4. Over the factors of the leading coefficient, once again, I was kind. The leading coefficient is 1. I won't always be kind. So let's list our possible rational roots. We are at plus -1, plus -2, plus -4, plus -8. Now I'm going to use the synthetic substitution. I need to get it down to a degree of 2. So I have to find how many that work. 2, because it's a degree of 4 right now. So that means I have to do the synthetic substitution to get it down to a degree of 2, which means I have to find 2 rational roots that work out here. Take your guess, any guess. Where do you want me to start?
No.
1?
4 -2.
Okay, so right off the bat, guys, right off the bat, I know 1's not going to work. How do I know 1's not going to work? Everything is a what? A positive. So if everything's a positive and I'm putting in a 1, a positive 1, will anything cancel? There's no way to get 0. So we got to be a little bit strategic here. All right, where do you guys? -4. Okay, let's try -4.
You mean no. This could be right.
-4. Let's do this. 1, 8. Oh, is this not it? That's not 1, 8. It's 1, 10. Sorry. 1, 10, 33, 38, and 8. All right. Bring down the 1. 1 times -4 is -4. 10 plus a -4 is a 6. 6 times -4 is a -24. 33 minus 24 is 9. 9 times -4 is -36. 38 minus 36 is 2. 2 times -4 is -8. 8 plus a -8 is 0. So now, guys, the root is -4, but what's the factor? X plus 4. Yes? Do we understand? So the root is -4, but the factor is x plus 4. Now the next factor is going to be this polynomial with these leading coefficients, but 1 degree less than the original. What was the original degree? 4th. So this is going to be a degree of cubed. So we're at x cubed plus 6x squared plus 9x plus 2. So now we're still going back to the original list. We're not going to make a new list. We're going back to the original list, but what are we taking off? Well, we're probably not going to try -4 again. So let's try another one on this polynomial now. -2, good choice. So now we're going to have -2 in the box, and I have a 1, 6, 9, 2.
We're trying it for that.
Yeah, you have to try it down because we have to get it down to a degree of 2. So, Dylan, if you went back to the fourth one to the degree of 4 again, you're back down to a degree of 3. So we keep taking the new polynomial until you get down to the degree of 2.
Oh, okay. So how do we find -2 though?
You still go back to the original rational roots.
Those numbers are still used.
All right, so we're at 1 times -2 is -2. 6 minus 2 is 4. 4 times -2 is -8. 9 minus 8 is 1. 1 times -2 is -2. We get a 0. All right, so now let's write out all the factors. What was the first factor we had? X plus 4. Now this next one, this is a root of -2. So if the root is -2, what's the factor? X plus 2. And now this one, now we had started at a degree of 3, so now we're at a degree of 2. So this is x squared plus 4x plus 1. All right. I cannot factor this. There are no factors of 1 that add to 4, but I am down to a degree of 2. So what can I use now? The quadratic. Here we go. So now we have, shh, boys, you're being rude to me. X equals -4 is one root. X equals -2 is another root. Now we're going to take x squared plus 4x plus 1, set it equal to 0, and use the quadratic formula. So remember, x will equal -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals -4 plus minus 16 minus 4 times 1 all over 2 times 1. So now we get x is equal to -4 plus or minus the root of 16 minus 4 all over 2. X will equal -4 plus or minus the root of 12 over 2. Can I simplify the root of 12? Yes, so x will equal -4 plus or minus 2 root 3 over 2. What can I do? Divide by 2. So x is equal to -2 plus or minus root 3. How many roots is this? 4. So we get x equals, what are the roots? -4, then we had -2, and then -2 plus minus root 3. That counts as 2 right there. Yay? You were happy about that? Okay.
Let's see what on our own. Can we do easy?
So I need to show you something. I need to show you something. X to the 4th plus 5x cubed plus 15x squared plus 19x plus 8. So where do we start off? Listing all the possible rational roots, all the possible rational roots. Possible rational roots. So once again, we are plus minus 1, plus minus 8, plus minus 2, plus minus 4. It's not really that nice. All over plus minus 1. So our possible rational roots are just our numerators. 1, 2, 4, 8, all plus minus. All right, so right off the bat, when you come to use the synthetic substitution, what do I know is not going to work based on the original polynomial? The positive numbers. Why are the positive numbers not going to work? Because everything up here is positive. So if we plug in and then just keep adding positive after positive, is there any way the last column will ever be 0? No, so that takes out half of our options, right? This. That takes that all out. So now we're going to test the negatives. Okay. Should I just tell you instead of torturing you?
It's -2. It's none of them.
So -1 works. -1 works. So you're going to go through and you're going to test -1. So you're going to have 1, 5, 15, 19, 8. One times -1 is -1. 5 plus a -1 is 4. 4 times -1 is -4. 15 minus 4 is 11. 11 times -1 is -11. 19 minus 11 is 8. 8 times -1 is -8. There's your 0. So then this brings us down to 1 degree less. What was the original degree? A degree of 4. So do we agree this is now going to be x cubed plus 4x squared plus 11x plus 8? And this is x plus 1. So I will tell you, so instead of torturing you, I will tell you right now, the others do not work. Silence for the suspense. Okay, so then what do? We're not at a degree of 2 yet. Since we're not at a degree of 2, am I allowed to use the quadratic? No. Aaron? There is a solution. You do -1 again. This is called a double root. What do I mean when I say a double root? So, guys, think of a parabola, right? If I have x squared minus 25 equals 0, right? If I have x squared minus 25 equals 0. Oh, wait, no, that's not going to work. Sorry, if I have x squared equals 0. Sorry, x squared equals 0. We end up getting x is equal to 0. But how many solutions is this? 2 solutions, but it's just 0. This 0 counts twice. This 0 counts twice because generally speaking, when you have a parabola, you come to the x-axis, you go through it, and then you come back up, right? So here's a root and here's a root. When you have a double root, meaning that number counts twice, like this one, what happens is it comes down, it hits that root, and then bounces back up. It doesn't go through the root. So it hits the root and then bounces back up. That's called a double root. So in this scenario, we have a double root. So what are we going to do here? We have to now do -1 again on the new polynomial to get it down to a degree of 2. On the new polynomial to get it down to a degree of 2. So now we are 1, 4, 11, 8. So we're -4, that's 0. And that's going to be 1, oh, sorry, I did -4. Guys, your no conversation's distracting me. That's -1. 4 minus 1 is 3. Hush, children. -3 is 8, is -8 is 0. So where does that bring us down to? X squared plus 3x plus 8. What are my other factors? Not roots. What are my other factors? Just x plus 1 and then another. So it's x plus 1 squared. Okay, so now I cannot factor this, but can I use the quadratic? Yes. So we're going to have x is equal to -3 plus or minus the root of 3 squared minus 4 times 1 times 8 all over 2 times 1. Simplify this down. Did anybody already simplify this down? Yeah, what is it?
-3 plus minus I root 23 all over 2.
Thank you. So we have 2 real roots and 2 imaginary roots. Is that okay? Absolutely. I'm going to have you do one by yourself and then you'll be done.
Like some absurd type stuff. She would believe.
No, why are you laughing?
It's a hard
I said 17 times.
Surely you can't be taught.
Does it not work?
No, it works.
Okay.
I just gave a leading coefficient, so now there's more options. I know.
What if we just pretend it's not there?
Good luck with that.
What if we use the decimal calculator? What if it just doesn't exist?
So on the test, we're going to have a calculator section and a non-calculator section. I don't know, to be honest. How many tests did we have this marking period? 4, right? We had 4 tests this marking period. We're done for this marking period.
No. Come on,
Huh?
Dad.
Post the homeworks? I don't grade every homework, but I will grade more homeworks.
I'll take one test. I'll take one more
For this marking period? I'm going to post more homeworks for this marking period, yes. For grades, yeah.
Oh my god, guys, I found it out.
So,
You have to literally go over everything.
huh?
Like, there's like,
So it's all about guessing lucky. Like, it's all about making the right guess. So this could take you an hour or it can take you like 5 minutes. It all depends on how good your guesses are.
dang, I'm bad at guessing. You know my bad?
All right, I don't think, do we think Kenny needs to see all this waiting? No, we're done. We're done learning. Bye, Kenny.